Okay, so hi everyone, Senan this side, and this video we are going to see how to solve this climbing stairs problem. So you are given a staircase. It takes n steps to reach the top. Each time you can either climb one step or two steps. In how many distinct ways can you climb the top? Okay, so looking at this, you know that could have a recursive solution, right? So at any point of time, if I'm the kth step, I need to know how many steps I require to reach k minus 1 and k minus 2. And if I know that, I can actually calculate the value of the kth step. So that is the whole point. For let's say you are at n is equal to 2, that means either you can take one step from 0 to 2 directly, or you can climb 1 first and then you climb 2. So for n is equal to 1, you can only take a single step, right? From 0th step, the first step, that is 1. For n is equal to 2, you can have 0 to 1 and then 1 to 2, or from 0 to 2 directly. So that is something we need to keep in mind. The case is n is equal to 3, so that there are three ways, because we just said to get to 2 we have two ways, to get to 1 we have a single way. Now to get to 3, either I can take two-step jump from staircase, or the stair 1, and I can take a jump of 2 to reach 3, or at staircase 2 I can take a jump of 1 to reach 3. So that is the thing. From 0 I can either take three single step, or I can take one single step and then take a jump of two steps, or I can take a jump of two steps and then take one step. Okay, so how do we go about solving this? So clearly, since we are dependent on the previous values that I had encountered, this is a dynamic programming question. So what I do is create a dynamic programming DP array of size n plus 1, because if n is, we have to reach the nth step, right? Not n minus 1. It's basically one based index. So I say solve for this, right? Solve for n steps. How many steps would take me to reach this nth step? So let's look at the solve function. So if n is less than equal to 2, I just return n. Assuming that n is always given to us as a positive value, right? If n is 1, we can go in one step. If n is 2, we can go in two steps. So that is both these base cases are given to you in this single if. Now don't look at this currently. Now how do I get the answer to this solution? So to get the value of n steps to reach the nth stair, I need to find how many steps it took me to find the steps, or I need to calculate the number of steps to reach the n minus 1th stair and to reach n minus 2th. And if I do this, I just return that file. So in this case, what I am doing is basically storing these values, because there would be multiple calls for the same argument. And we'll see basically this in the notebook after the explanation of all three solutions. This is the memoization approach. So you memorize every time you see a DP array that is not initialized to -1. That means you had calculated this value sometime in the past. So what you do is you just return DP of n. So that is one thing. The next is tabulating this code, because at DP of, so the base case was what? N is less than equal to 2, return n. So DP of 1 is 1, DP of 2 is 2. Now for every next element, what I need is DP of I, the next element, is equal to previous element and 2-step previous element. So that is what I am basically calculating in this. And in the end, I return the value of n. So this is basically the same thing. This is memoization. This is the tabulation approach. You are not calling a recursive function, you're just calculating the subproblems by yourself. And we started this from I equal to 3 because 1 and 2 are already. Now if you look at this properly, for every I you just need two values, right? So rather than storing a full vector of n plus 1 elements, I can just carry two elements, the previous two elements, and I can store that. So you can just modify this, rather than not be, you can modify this to not having a vector at all. So the previous is 1, the current is 2. Now for I is equal to 3 to n, same code, but now what I do is, first of all, I have base case. If n is less than equal to 2, I return n. Otherwise, I know they are to initialized, and we would get into this for loop at once. Now the next element, the next value would be the current value and the previous value, right? And I just store the, for the next iteration, I store the previous value as the current value and the current value as the next value. So I'm just keeping track of the last two elements. And in the end, after I reach I equal to n, so the value would be stored in what? Next. And after this for loop, the next would be stored into the current variable, and I just return. These are basically the three approaches First is the normal DP approach. The next is the memoized approach. So DP is the memoized approach. Then what I use is the tabulation approach. And since I know I only need the last two elements, so rather than carrying the whole vector with me, I just carry the last two elements. So that is the optimized way, because this I'm not using any. So the time complexity would be big of n for this. Space complexity is constant. Now let's look at the notebook and see why we are having a recursive approach or a dynamic programming approach. Okay, so in this case you have, let's say, staircase, right? For example, now what I would do is I'll mark this as 1, as 2, because it takes one step to reach here, one step to reach here, and to reach 3, how many steps do you require? Is 2 plus 1, which is what is 3 again. And how many steps do you require each? 4. It's what you can get to 3 with 3 steps, then 2 with 2 steps, and you can just add them, get the value of this. So what you get is 5 in this case, and 5 you get 8. So if you observe this, what is this? Is this sequence known to you? So first start with 0 1, then add them, you get this number, then add these two elements, you get this number, add the last two elements, you get 5, last two elements, you get 8, 13, 21, 24, dot dot dot. So what is this sequence? This is actually the Fibonacci sequence, right? So this climbing stairs is a different name. Basically it is trying to ask you write a Fibonacci function for getting the Fibonacci sequence. Now let's look at the recursive call and understand why we are going for a dynamic programming approach. So let's call this function for value of 5. So we know value is right because we've seen this, right? So now what this would do, for 5 you need the value of fourth Fibonacci number of 3. Basically not exactly Fibonacci number, something like this. Now for 4 I need to call for 3, and 2 for 3 I need f2, f1, and I'm done, because of 2 and 1 were my base case. Again, this is again my base case. This 3, what I have is basically called f2 and f of. So this would return 1, this would return 2, return 1, return 3, return what, 2. So this would return 5 to this. So this 3 would return 3. So this returned 5, this returned 3. In the net, you return 8. You see, you had calculated f of 3 at this point and at this point, right? So you have calls for the same subproblem. So that is why you are going to use dynamic programming. Once you solve this, you would store this value in the array. And when you see this, that the value of dp of 3 is not equal to -1, that means you had solved this problem sometime before. So what you do is just use the value that you got here and return that. You don't even go into these calls. So in that case, you would have a linear time solution rather than an exponential. So calculating Fibonacci by recursion without any DP array, it's an exponential order. So basically time complexity is big O of n. Time complexity is big O of 2 to the power n when you don't consider the repeated subproblems and you just calculate it every time you see one. So when you are using a DP approach at 5, 4, 3, 2, 1, and at this point you just return back. Whenever you go to the right tree at any point of time, you would realize you would have already solved these values, so you won't be going into the right subtree, you will just directly return a value. So in that case, you would get a linear time approach. If you use the optimized approach that I told you, the next and the previous one, you improve on the space complexity, because the only thing you're dependent on is 5 is dependent on this value of 4 and 3. So you can just, rather than using a whole array, keep track of last two elements. So yep, that was the video. It was an easy problem, so hope you were able to get the logic by yourself. And yep, thanks for watching, and I'll see you in the next